let's talk about something we all use literally every second, but probably don't think much about: the network. We're going to pull back the curtain and map out the hidden superhighway your data zips across every single time you send an email or stream a show. So seriously, have you ever stopped to wonder what really happens in that split second after you hit send? It feels like magic, right? One moment it's on your screen, the next it's halfway across the world. Well, it's not magic. It's actually a brilliantly designed system, and we're about to trace its exact path. To really understand that journey, we first have to get to know the engine that powers everything on your local network. It's a technology called LAN switching, and it's the heart of the whole operation. So what exactly is it? Well, at its core, LAN switching is a clever way of handling data. See, your email or photo gets broken down into these little pieces called packets. But the real genius is right there on the screen. The data is sent only where it's needed. Instead of just shouting your information to every single device on the network, a switch acts like a super efficient mail carrier, delivering each packet only to its specific destination. This is an absolute game changer for keeping things fast and avoiding those frustrating slowdowns. But here's the thing, just having smart switches isn't quite enough, especially when a network grows from a handful of computers to thousands. You need a plan, a blueprint. And in the world of networking, the gold standard is this 3-layer map. And here it is. This is the hierarchical network model, the blueprint we were just talking about. It looks simple, but it's incredibly powerful. You've got 3 distinct layers: access down at the bottom, distribution in the middle, and the core right at the top. Think of this as our roadmap for the rest of this explainer. Okay, so now that we have our map, let's actually see how it works. We're going to follow one tiny data packet on its big journey, starting from your device and heading out to the great wide internet. Our packet's journey starts right here at stop number 1, the access layer. This is basically the on-ramp to our data superhighway. It's the layer where all the devices you actually use, your computer, your IP phone, the office printers, physically plug in and get connected to the network. After hitting the on-ramp, our data packet immediately travels up to the distribution layer. Now, if the access layer is the on-ramp, you can think of this layer as the network's main traffic controller. Its job is to gather up or aggregate all the traffic coming in from the different access points and start applying the rules of the road. The network policies that decide which data gets priority and where it all needs to go. And finally, our packet makes it to the top, the core layer. This is it. The backbone, the superhighway itself. Its job is singular and absolutely critical: to switch data at incredibly high speeds. This is the gateway that blasts communication from all the lower levels out to other networks and the internet. Here, speed is everything. Okay, so we've seen the map and we've followed the packet's journey, but why? Why go to all this trouble? Why is this hierarchical structure so important? Let's break down exactly why this model is so good at what it does. It really comes down to these 5 huge advantages. First, scalability. With these clear roles, you can grow your network, add a new building, hundreds of new users, without the whole thing descending into chaos. Next up, redundancy. This one's huge. If one switch or cable fails, the hierarchy provides backup paths, so you stay connected. Then there's performance. You can put your fastest, most powerful gear where it matters most, at the core. You also get way better security because you can apply specific rules and filters at each layer, like checkpoints on a highway. And finally, manageability. This logical structure just makes it so much easier to find and fix problems. So, knowing the theory is great, but building this thing in the real world means making smart choices about hardware. And that means picking the right switches for each specific job in the hierarchy. Generally speaking, switches come in 2 main flavors. On one side, you have your fixed configuration switches. With these, what you see is what you get. The number of ports is set in stone. They're perfect for that access layer, where you pretty much know how many devices you need to connect. On the other side, you've got modular switches. Think of these like Legos for your network. They're built for flexibility, letting you add new modules with more ports or different features as your needs grow. And this table really brings it all together. Take a look at PoE, or Power over Ethernet. You know how your office phone gets power right from the network cable? That's PoE, and it's why it's so important down at the access layer, where those devices live. Now look at Layer 3 support. All this means is the switch is smarter. It can make routing decisions. It's kind of optional at the bottom, but it's absolutely essential at the top. And of course, you see speed just ramping up as you move up the hierarchy. You're talking gigabit speeds for users, then 10 gigabit in the middle, and 10 gigabit or even faster for the core backbone. So the whole point comes down to this. Pretty much anyone can plug a few computers together and make a simple network. But as our source material perfectly puts it, LANs are easy to establish, but complex to maintain. This hierarchical model is the proven, time-tested solution to that complexity. It brings order and reliability to what would otherwise be a complete mess. When you think about it, this entire invisible structure, these layers, the switches, all the rules, is what makes our modern connected world even possible. Which kind of leaves you with a final thought, doesn't it? Our digital world absolutely runs on these hidden, invisible systems. What other secret structures are out there quietly powering your day?